Now we are live. Yes, now we are live. Thank you. Thank you. Thank you for waiting. Thank you. So today in this session, we will be doing the revision of circles. Last time I was not able to take the class, so that's why Tabish sir took the class. No, Tabish sir took the session. So he did cover number systems, and you guys asked me to do circles. Hello Tamanna, how are you?
I'm fine, sir.
Fine. Now, in this chapter, from this chapter, you can expect theorems majorly, correct? So that's why I did created the PPT, which is having all the important theorems from this chapter. So I will be explaining how to prove them. Okay.
Yes, sir.
So after the session, if you want me to create one more class where I should be giving you problems only, then I can do that. But for this session, I did included all the theorems that is out there in this chapter. So should we start?
Yes, sir.
Okay. Then one second. Okay. So the first theorem is the statement is the perpendicular from the center of a circle to a chord bisects the chord. First, we need to understand everything what is given in this statement. Do you guys know how to prove this? How to prove this theorem? You know, everyone? You know? Okay. First, we need to understand what is given in this statement. The perpendicular from the center. So the first thing that is given to me is the perpendicular. And from where? From the center. So O is the center. In this circle, O is my center point. AB is the chord. Chord is what? A line segment joining any 2 points on the circle. That's why diameter is the longest chord. Now, AB is the chord, and we are saying the perpendicular from the center of a circle to a chord. So we are drawing a perpendicular from the center. This angle is 90 degree then. Yes. So we need to prove that this perpendicular is bisecting. What do we understand by this term bisect? What is bisect?
Divides equally.
Divides equally in two equal parts. Very good. This bi, wherever you see this bi, na, it means two. Do we know any word which starts from bi? Bicycle? Bicycle, we know.
Yes, sir.
Binomial, very good. Isha, binomial. Any other example? Biology, binary. Biology, why biology? Study of male and female. That's why biology. Binary numbers are 0 and 1, two values. Correct? So wherever you can see bi, it is indicating that it is related with two. So bisect matlab, bisect means we are dividing this chord, this line segment AB in two equal parts. How to prove this? The main point is how to prove this. So consider a circle. Of course, you need to write everything in your exam. Now you need to write everything, whatever construction you are doing, whatever thing you are considering. So we are considering a circle with center point O. You need to write it like this. Consider a circle with center O and let AB be a chord in it. So you can consider AB anywhere. AB can be a chord anywhere inside this circle. Suppose I am going with this. Now, draw a perpendicular. Why we are drawing a perpendicular? Because of this statement. Because first we need to draw the perpendicular from the center of a circle to the chord. So this is the perpendicular from the center, and it is gonna meet AB. We are gonna name this point as point C. So OC is the perpendicular. Done. Now what? How to prove that AC and BC are equal? Bisecting means that we need to prove AC is equals to BC. I think when we can solve this problem with yes, congruence. When we are doing triangle chapter, then I told you that this chapter is very important because the concept related to triangles you are gonna apply in whole ninth class. Everywhere you are gonna use triangles, 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 congruence, right? So we are gonna use congruence here also. So to apply congruence rules, we need what? What is the basic necessity of applying congruence rules? We must be having triangles, correct? Then only we can apply the congruence of triangles, no? So is there any triangle that you can see? Is there any? There isn't. So first, let's create some triangles. We can join A to O. Yes, we can. And also, if we are joining with A and O, then we are gonna get one triangle, B to O. So we are gonna join the center point O with A and with B, like this. Now, what can I see here? Without looking at the proof, can you tell me anything about these two triangles? Anything? AO is equals to BO because they are radius, yes. A line segment which is joining the center of the circle with any point on the circumference on or the boundary of the circle is known as radius. Inside a circle, the value of radius will remain the same anywhere. So I can see that OA and OB are two line segments which are joining the center point and one of the points on the edge of the circle. So it means OA and OB both are radius. Radius of a circle are equal. So it means we can say that in triangle OAC and OBC, we can notice three things. First thing, that angle OCB and OCA, both of them are equal. Why is that? Two line segments, when they are making 90-degree angle on one side, then they are also making 90-degree angle on the other side, right? We know this. So both are 90 degrees. So it means angle OCA is equals to angle OCB. Both are 90 degrees. Also, OA and OB are equal because both are radii of the same circle. Third thing is that OC is equals to OC. This one side OC is common for both the triangles. If it is common, then of course it is equal only. Correct? Now, if I'm looking at things, then I can see this side and this side, they are equal. This side, it is common, and this is 90-degree. Hypotenuse of this right angle triangle and hypotenuse of this right angle triangle, they are equal in length. One of the side of these two triangles is also equal. So we can apply RHS congruence rule. And we can simply state that triangle OAC is congruent to triangle OBC by RHS congruence rule. Correct? If they are congruent, then we can use our biggest weapon. I always call it the biggest weapon of ninth class. Do you know what is the biggest weapon? CPCT, actually. Thank you, Kesia. CPCT is the biggest weapon that you can apply in ninth class. Because of CPCT, you can score around 30 marks in your exam paper. CPCT, CPT, CT. Prove triangles congruent, CPCT. Congruent, CPCT. So it is the biggest weapon that you can use. When you are gonna reach 10th class, then you are gonna use CPST. Okay, let's not go there. Okay. Now, if these two triangles are congruent, they must be having same shape, they must be having same size. So everything, all the corresponding parts of one triangle are equal to all the corresponding parts of the other one. If they are equal, you can use them. You can use the info, because the things that we need to prove they are equal are nothing but the two sides of these two triangles. Correct? AC and CB. So by CPCT, we simply say that AC is equals to BC by CPCT. Corresponding parts of congruent triangles. We know the full form, no? CPCT is corresponding parts of congruent triangles. This implies that OC bisects the line segment AB. Because if these two are equal, AC and BC, they are nothing but two parts created by this line OC, which is perpendicular falling from the center. According to the statement of this theorem, that a perpendicular drawn from the center of the circle onto a chord is going to bisect the chord is true. Then. Hence proved. So in the end, you need to write it like this. Hence proved. Very easy proof. How to prove? Just create the triangles. First, you are going to consider a circle with center O or whatever alphabet you want to choose. Usually we go with O only. Then you are going to consider a chord. I'm going with AB. Then you are going to draw the perpendicular. This is according to the statement that we have done everything till now. Then we are going to do what? Of course, we are going to use the congruence. So we need triangles. So we are going to join OA and OB. Now you can see two triangles, OAC and OBC. In these two triangles, we can see that they both are right angle triangle because angle C is 90 degree, and also we can see hypotenuse are equal and one of the side is also equal. Then simply two triangles are congruent. If they are congruent, we can apply CPCT, corresponding parts of congruent triangle, and the things that we need to prove they are equal, we can prove them using CPCT. AC is equals to BC. So it does prove the theorem. Easy proof. Now, second one. So this one is nothing but the converse of the previous theorem. So the statement is the law. Sorry. Hello, Samyukta and Sravya. Welcome. Now, the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. This is nothing but the converse of the previous theorem. In the last theorem, we understood if we are drawing a perpendicular, then that from the center of a circle onto a chord, then that perpendicular is going to bisect the chord. But this time we need to prove that the line drawn through the center of a circle to bisect the chord is perpendicular to the chord. So the given thing is that this line that we are drawing is bisecting this chord AB into equal parts AC and BC. We need to prove that OC is perpendicular. So again, you need to write everything that you are considering a circle with center O. You are gonna create the image. Then AB is the chord like this. Then a line segment through a line segment from point A. You are gonna draw in such a way that it is bisecting the chord AB. The point of intersection of this line and this chord is point C. Everything you need to write it like this. Then it according to this statement, AC is equals to BC. Okay, what should be our approach here? Anyone having any idea? What should be my approach? How to prove this? What can
Yes,
we do?
that's congruent.
Again, we need to use one thing, congruence. So to apply congruence, we need triangles. Correct? So now join the points O and A and the points O and B. We are gonna again join OA and OB, the radius. Use SSS congruence. Yes, we can use SSS and then CPCT. Very good. Excellent. So the two triangles that we can see are AOC and BOC, like this. In these two triangles, we know certain things. We need to prove that these two angles are equal, correct? Or they are 90 degree. This side and this side, they are equal, given part. This side and this side, they are equal because they are radii of the same circle. And this side is common, so it is equal only. So we can use SSS congruency. SSS stands for side, side, side. According to that criteria, if all the three sides of one triangle are equal to all the three corresponding sides of other triangle, then the two triangles are congruent. Correct? So same logic we are going to apply. You need to write everything like this in triangle AOC and triangle BOC. One thing that you need to be very careful about here, incongruence in general, is that the naming of the triangles. You can name them AOC and BOC only. You cannot randomly put the names because the naming should be done very carefully. The corresponding parts should match in the naming also. Essentially, you are saying that angle A is equals to angle B, O is equals to O, C is equals to C. Also, AO and BO are equal, OC and OC are equal, AC and BC are equal. So please be very careful about the naming of the triangles. Now, in these two triangles, AC is equals to BC, is the given part. OA is equals to OB, radii of the same circle. OC is equals to OC, the common. So it means two triangles are congruent by SSS congruence criteria. Where is, sorry sir, issue of laptop? Oh, no problem. Veer, welcome.
Thank you, sir.
So now the biggest weapon, correct? If we are proving two triangles to be congruent, of course we are doing it for only one thing, that so that we can apply CPCT. So these two triangles are congruent. It means angle OCA is equal to angle OCB. If these two angles, these two, they are equal and they are also making one thing, no? What are they? Their sum should be 180, correct? Yes, yes. So their sum should be 180. So angle OCA plus angle OCB should be 180 degrees. They are equal, so I can consider, suppose the value is x. So 2x is 180 degree, x is 180 by 2, that is 90 degree. So both of them are of same value, that is 90 degree. So that's why they both are equal. And that is what we need to prove, that OC is perpendicular to AB. A line is perpendicular when that line is making 90-degree angle with the other line or whatever is correct. This is the proof. Again, to prove theorems related to circle, we are using properties of triangles. Now, third one. One second. Now, this theorem is, I think this one is very important because yes, because of this statement. What is given to us? Equal chords of a circle. Equal chord means they are equal in length. Equal chords of a circle or of congruent circles are equidistant from the center or centers. So we need to prove that if we are having two chords in the same circle or in two different circles, but the circles are congruent. When can two circles be congruent? When they are having same radius. Then they are congruent. Equal chord means the length of the chords are equal. So if we are having two equal chords, suppose one is here, in the other one, suppose it is here. A, B, and C, D are two chords, suppose. They are equal in length. Huh? Then we need to prove that they are equidistant from the center. What is the distance of any chord from the center? What is the distance of any chord from the center? Anyone? Radius.
The distance is equal from the center.
What is the distance of any chord from the center? Radius? No. Radius is not the distance. Perpendicular bisector, yes. The perpendicular that you can draw from the center onto the chord. That perpendicular is nothing but the distance between chord and center. Very good. Now, I'm going to consider two chords, AB and CD. So their perpendicular distances are, this is the perpendicular distance of AB, D1. This is the perpendicular distance of CD, D2. Now, I'm considering AB and CD in such a way that they are equal in length. And what we need to prove? That D1 and D2 are equal. We need to prove that this distance is equal to this one. So we are going with different naming, D1 and D2. Correct? Then we are doing one thing. I'm joining A with O, B with O, C with O, D with O. Why we are doing this? Because of course we are gonna again rely on the properties of triangles. We need two triangles. So what better way to join the radius? OC, OD, OA, OB, all four of them are what? Radius? Radius, no? This is the easiest proof
Yes, sir.
of any theorem. This is the easiest. Why? Why? Anyone having any idea why this is the easiest? Already too many things are given to us, no? All four of them are equal because they are radius. AB is equals to CD. Why? Because of this statement. In this statement, it is already given. Yes, all three sides are equal. Very good, Athar. So we are considering that OA is equals to OB is equals to OC is equals to OD. This we know because they all are radius. The value of these are equals to small r. We can do that, correct? Now, in these two triangle, OCD and OAB, we can see that OA is equals to OC, radii of the circle, OB is equals to OD, radii of the circle, AB is equals to CD, the given part. So all three sides of this triangle OAB are equal to all three corresponding sides of OCD. It means two triangles are congruent by SSS congruence. Because of lines. Lines what? Veer? What is because of line? Did I miss something here? Veer? These sides as in OINES. Okay, okay. Okay. Yes. They are equal. No? Now, these two triangles are congruent. Why we are proving them that they are congruent? Because we are going to apply this thing. Two things, two shapes, when they are congruent to each other, they are having same shape, also same size. Same shape we understood, that circle, circle, triangle, triangle, same. Size means that the area of this thing, the first figure, is equals to the area of the second one. Right. If the areas of these two triangles OCD and OAB are equal, then first let's find the area of this triangle OCD. Area, how to find the area of any triangle? The formula is half into base into height. This is the formula, right? Now look at this triangle ABC. I can find area of this triangle ABC in three ways. I can consider three sides, all three of them to be my base. Then for each one of them, I will be having different height. No? Correct?
Yes, sir.
Suppose if I'm considering BC to be my base, then I need to draw a perpendicular from the opposite vertex A. So it will be something like this. So this is the perpendicular. Suppose the height is h1. So the area of this triangle will be half into BC into h1. Now suppose if I am considering AC to be my base, then I need to draw the perpendicular from the opposite vertex B. Suppose this is h2. Then area will be half into AC into
AC into H2.
h2. If I am considering AB to be my base, then I need to draw the perpendicular from C, h3 suppose. So area will be half into AB into
AB
h3.
into H3.
H3. Now, let me ask you one thing. Although we are using different values, BC, AC, AB, H1, H2, H3, but the final value will remain same or not for all three of them? Will it remain same?
Yes, sir.
Because they are nothing but the area of the same circle, no?
Yeah.
So the final answer will remain same only. Now here, I'm gonna do one thing. In this triangle OAB, as this is the perpendicular, so
Yeah.
I'm gonna use this perpendicular D1. So what should be my base then?
AB.
AB should be my base
AB.
because this D1 is falling from the opposite vertex O on this base AB. So the area of triangle OAB is half into AB into D1. Why I want to use D1 only? Because I need to prove D1 and D2 to be equal. Correct? Now,
Yes, sir.
same logic we can apply here. Area of the triangle OCD. What we need to use? D2. So D2 we can use by taking CD as our base. So area of the triangle OCD is half into CD into D2. These two triangles are congruent. Their areas are equal or not?
Yeah,
Are they
there.
equal? They
Yeah.
are equal. Correct. So we can equate these two values.
Yeah.
So let's do that. If we are equating, so half and half can cancel each other. Now, let me ask you one thing. Can we cancel AB and CD?
Uh, yeah, because they're congruent, right?
Yes. Because it is given that these two chords are equal. So we can cancel them. It is already given, no? That AB and CD are equal chords. Correct? Now, after cancelling, what are we left with? D1 and D2 only. So from here, we are getting D1 is equals to D2. Isn't it the same thing that we need to prove?
Yes, sir.
So it means
So
the
they're
two equal chords are equidistant from the center of circle.
center.
See, we are using only one circle to prove this. If you want, you can go with two circles also, having same radius. Huh? Then you can plot the center point, suppose O1, O2. Then you need to draw two chords in such a way that they are equal. So steps are same only because they are congruent circle. So radius are equal, and this is already given as equal. Correct? Then you can
So
consider two
SSS,
distances. Then equate the areas, and you are gonna end up with D1 is equals to D2. There's one more way to prove this. Should I tell you? Without using the area part. Should I tell you?
yes, sir.
See, we are done with congruence. We proved that these two triangles are congruent, OCD and OAB, correct? Then two triangles are congruent, their corresponding parts are equal, correct? Now, I'm gonna take this as A. So this is also A, they are equal. Huh? These two angles are corresponding angles, they are equal. Now, let me ask you one thing. Suppose this is point E and this is point F. Look at this triangle and this triangle. In these two triangles, half of AB, this is half of AB, this is also half of AB, half of CD.
Yes,
AB
sir.
is equal to AB is equals to CD. Half of AB is also equals to half of CD.
Yeah.
Correct? Half of AB is what? EB. So it means EB is equals to half of CD is what?
CD.
FD. FD, sorry. This is F, sorry.
Oh.
Hmm? So EB and FD are also equal. Now look at OB and OD. They are also equal. They are radii of the same circle.
Yeah, yeah. Yeah.
And the angle included between these two is also equal because we did conclude it using CPCT.
Yeah. And
So
then we can find out D1 equal to D2 by CPCT.
CPCT because these two triangles are congruent because of SAS, side angle side.
Sir, we can also, no, wait, we can't. Sorry.
Please come again.
No, I thought the right angle because RHS, but no, the height we didn't find yet.
No, but we know one thing. See, if you want, you can use RHS also. Very good. How? See, this is perpendicular and this is also perpendicular. Theorem number
Yeah,
one is what?
90 degrees.
Yes, the line drawn from the center will always be perpendicular. This we already proved, na? So this is 90
Yeah, yeah.
degree. So then you can use RHS also. Because hypotenuse are equal and this side, if you can prove, yes, RHS also. So there are multiple ways. Now, this one. The statement is chords equidistant from the center of a circle are equal in length. It means the converse of the previous one, isn't it? The chords equidistant from the center of a circle are equal in length. We need to prove the converse of the previous theorem. So first thing first, we need to consider a circle with center O and radius R units. Now, again, same type of diagram you need to draw where you are considering AB and CD, but this time we are not sure they are of equal length or not. We are not sure about this.
Yes,
We
sir.
need to prove this. But one thing is given to us that this distance and this distance they are equal. They
So
are
we use the converse of the first theorem.
converse of the
Of the theorem that you
converse of the
just
first
taught.
one.
No, like the one before this.
Okay, okay, okay. Let's see how to prove this. See, OC, OD, OA, OB, they all are radii of the same circle. So consider
Yeah.
their value to be R. Now, let the point of intersection of the perpendiculars in A and B named as M and N. So we are gonna name these two M and N. Now let the distance between the center and the chords be D units. Why D units? Because it is already given that they are equal. So we can use single value D. There are four right angle triangles formed. Can you see all four of them?
Yeah.
First, second, third, and fourth. All four of them. Now, in triangle OA, this one, let me highlight this one, OA. In this triangle, we can apply Pythagoras theorem, right angle triangle. So, of course, Pythagoras theorem. So, according to one of the greatest mathematician Pythagoras, that the square of hypotenuse will always be equals to the sum of the squares of other two sides.
Yeah.
Correct?
Yes, sir.
OA is the hypotenuse here. OM and AM are the other two sides. So OA square is equals to AM square plus OM square. From here,
Yeah.
we can see one thing, that AM square can be rewritten as OA square minus OM square, isn't it?
Yes,
Why we
sir.
are going with AM only? Any idea? Why we are going with AM square as OA square minus OM square? Because out of
Uh,
these three sides,
we have
what
to prove
we
that
know,
the
this is R, this is D. Value of these two are known to us, correct? Not the
yeah.
exact, but we are using some variable, no? So R and D. Only the AM is not known to us. If somehow I can prove that AM, MB, CN, and D, they are all are equal, then we can add the two parts, and then we are gonna get what? That AB is equals to CD, correct? So
The
this should be our
they're
answer.
equal.
Yes. So AM square is OA square minus OM square. OA square radius. So R square. OM square the distance D square. Similarly, BM square we can similarly find the value of BM, no? BM square. What is BM square? R square minus D square. Correct?
Yes, sir.
Because you can apply the Pythagoras theorem here also. Same way you can find the value of DN in this triangle and CN in this triangle. So all four of them are equal only in length, and that is R square minus D square, R square minus D square, R square minus D square. So hence AM is equals to BM is equals to CN is equals to DN. All four of them are equal. Now let me ask you one thing. If I'm having four values, suppose x four times. So x plus x is equals to x plus x, no?
Yeah.
Correct? 2x is equals to 2x.
Yeah.
If all four of them are equal in length, so AM plus MB is equals to CN plus ND, isn't it?
Yeah.
They are equal. What is AM plus MB?
AB.
AM plus AB. Very good. And what is CN plus ND?
CD.
CD. And this is what we need to prove, that AB is equals to CD. AB is equals to CD. Correct? Therefore, in a circle, if chords are of equal length, then they are at equal distance from the center of the circle. And vice versa is also true. Understood? Someone is saying, hello, sir. Hello. Hello, Hardik. Yeah. Next one. This statement. First, we need to understand the statement of the theorem. What is this statement? The sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree. We know the concept of cyclic quadrilateral. No? A quadrilateral which is cycling. No? What is cyclic quadrilateral?
A circle in which a quadrilateral is present where all the four vertices of the quadrilateral are touching to different points of the circle.
Correct. I think Asia also want to say something. No?
Yes, sir. A
Yes, Asia.
quadrilateral in which all the vertices lie on the circumference of the circle.
Very good. So, oh, one second, guys. Okay, sorry everyone. I had to take this call. Yeah, a cyclic quadrilateral is something which is inside a circle, which is circumscribed by a circle. Now, the vertex, the four vertex, because a quadrilateral is having four side and four vertex, all the vertex should be touching the boundary of the circle, the circumference of the circle. Now, suppose if I'm having a circle like this, and suppose two sides are touching the boundary, but one of them is not touching. Can I call this ABCD a cyclic quadrilateral?
No, sir.
Yes, we can. Four corners lie on a single line. Single line, Dhanush. How can all four corners of a quadrilateral lie on a single line? I think you want to say that all the four corners are lying on the boundary of a single circle. Yeah, single circle. Then correct. Now, so we need to prove that either pair means that there are two pairs of opposite angles. No, opposite angle should be 180. Yes, that we need to prove. Correct. Now, either pair of the opposite angles of a cyclic quadrilateral is 180 degree. It means what are opposite angles? The angles which do not have common side between them. Correct. So A and C are opposite angles.
Yes, sir.
B and D are opposite angles. We need to prove that the sum of B and D is 180 degree. A and C is also 180 degree. Now, what is the angle sum property in case of quadrilateral?
Uh, A plus angle B plus angle C plus angle D equal to 360 degrees.
360 degrees. We know the formula that in case of any polygon with n sides, we can apply this formula n minus 2 into 180 degree to find the angle sum property of that shape. N is the number of sides, correct? You can apply this formula. In case of quadrilateral, how many sides are there? 4. So n
4.
is 4. 4 minus 2, 2.
2.
2 into 180 degree, 360. So
360.
it means the sum of all the interior angles of this of any quadrilateral will always be 360 degree. Also, we are saying if the quadrilateral is cyclic, if all the four vertices lying on a same circle, then opposite degree. So A plus C is 180, B plus D is 180. 180 plus 180, 360. Okay, so we can prove this. Correct? How to prove this? Any approach? Anyone having any idea? No?
Do we use the diagonals to make it to two different triangles?
See, we know this concept. Let me remind you of this concept. Suppose this is a circle with center O. Huh? I'm gonna draw a chord AB. So angle subtended by same chord. If AB is subtending an angle here, suppose this is point C. So this ACB is the angle subtended by chord AB on the major segment. This is major segment, no? This
Yeah.
ACB is the major
Yeah.
segment, and this suppose this is point D. So ABD is minor segment.
Minus segment.
Angle subtended by ACB is that angle which it is subtending on the major segment ACB. Same AB is also subtending, suppose this angle, and this is point E.
Yeah.
Do they have any
It is
relation?
uh,
Angle 1 and angle 2.
yeah, they are both equal.
They're
And
equal.
since AB is a straight line, the angle is 180 degrees, and angle 1 and angle 2 is equal to half of 180 degrees, which is 90 degrees.
Come again. AB is a straight line. Okay.
And because AB is a straight line, the angle is 180 degrees, and angle 1 and angle 2 is equal to half of 180 degrees, which is 90 degrees.
I don't think so. That is true in every case. That every time it will be 90. No, it will not be 90 in every time. Every time it will not be 90. Of course, AB is a straight line. Of course, it is. But the main point here is that the angle subtended by AB anywhere on this major segment will always be equal. It will always be equal. That is the main point. Now, the same concept we are going to apply here also. Angles subtended by a chord in the same segment of the circle are equal. So, ACB. So, look at this AB. ACB is this angle, no? So,
Yeah.
AC angle is the angle subtended by chord AB in this segment, ADCB, right? The major segment. The same chord AB is also subtending this angle, no? ADB. It is.
Yeah.
So it means these two are equal. Angle 1 and angle 2 are equal. Also, BAC. BAC. This angle. Suppose this is angle 3. BAC is the angle subtended by BC on this segment BADC. This is equals to BDC. This one. These two are equal. Why? Because both of them are subtended by the same chord BC on this same segment, major segment of this circle. There you go. Correct? Now, look at this. 2 plus 4 is gonna give me what? Whole angle.
ADC.
Yes.
Angle D.
Angle D or angle ADC. Correct? So 2 plus 4 is angle ADC. Now, adding equation 1 and 2. We are gonna add these two. This equation and this one. Now, after adding, the LHS will become ACB plus BAC. ACB plus BAC. Okay, no problem. Other side is ADB plus BDC, this whole. Correct? So this is gonna give us angle ADC. This will remain as it is. Now this is my equation number 3. Now, in triangle ABC. So in this triangle, what is the angle sum property of a triangle? N minus 2 into 180 degree. What is n in case of triangle? 3.
Yeah.
3 minus 2, 1. 1 into 180 degree, 180.
180 degrees.
So sum of all three interior angles of any triangle is always 180 degrees. Look at this. This angle, and this whole angle. The sum of these three should be 180 degree. We can rewrite
Yeah.
this situation because here, what are we using? This angle and this angle. Suppose this is angle 1 and this is angle 2 and this is angle D as it is. So this is same angle 1 and 2, but this time we are going with angle B. Sum of these three is gonna give me 180 degree. But sum of these two, angle 1 plus angle 2, is gonna give me what? 180 degree minus angle ABC.
ABC.
Correct?
Yes, sir.
It will give me A is equals to B and B is equals to C. Can I say A is also equals to C? If A is equals to B, B is equals to
Yeah.
C, A is also
Yeah.
equals to C. Now look at this. ACB plus BAC is equals to ADC. Equation number 3. Hmm? Angle 1 plus angle 2 is equals to this angle D. But here we are proving angle 1 plus angle 2 is equals to 180 degree minus ABC. If they are equal to same value, we can equate them. After equating, we are gonna get angle ADC is equals to 180 degree minus ABC.
Yeah.
Correct?
Yeah.
Now we can transpose this ABC to the left hand side. We are gonna get angle ABC plus angle ADC is equals to 180 degree. Or in simple language, angle B plus angle D is equals to 180 degree. Either pair of the opposite angles of a cyclic quadrilateral is gonna give you sum as 180 degree. B and D are nothing but the opposite angles of this cyclic quadrilateral ABCD. The sum of these two is what? 180 degree. This is what we need to prove. Correct? Same way, you can prove for the other two values. Or you can use this concept that because of this angle sum property of quadrilateral, the sum of all the interior angles of this quadrilateral ABCD should be 360 degree. So A plus B plus C plus D should be 360 degree. B and D, the sum of these two, we already know 180 degree. So 180 degree plus A plus C is 360 transpose. A plus C is what? 180. This is what we need to prove. And this is what we did. Correct? Hello. You can hear me, no?
Yes, sir.
No. So this is what we need to prove, and this is what we did prove. That sum of opposite angles of a cyclic quadrilateral is always 180 degree. Now this one problem you need to solve. In cyclic quadrilateral ABCD, if angle A is 70 degree and angle B is 110, you need to tell me the value of C and D in chat box. Huh? Everyone, please tell me the value of angle C and D in chat box. First, I'm gonna create an image. Right? Angle A, angle B. Sum of opposite angles are always 180 degree.
180 degree.
A and C are opposite. So sum of A and C should be 180. So A plus C is should be 180 degree. Value of A is 70 degree. So C is 180 minus 70, 110. Hmm? And same we can apply for B. B plus D is 180 degrees. B is given to me 110. So D is 180 minus 110, 70 degrees. Correct answer. Everyone. Correct answer, everyone. So we are done with the session, anyone is confused in any theorem, please do let me know. I can again explain the theorem. In this session, I only included the theorems only because from this chapter, na, majority of the time examiner is gonna ask you the proof of any theorem. Correct? Now, if you want, I can create one more session where I will be including only the numerical problems. But there's not much in this chapter. Sir, could you show the second page of the cycle? Why not? This one is the first one. This page you are asking, no? Veer? Anyone having any issue in any theorem, please do let me know. Thank you, sir, with the question mark. No. Anyone having any problem in any theorem, the proof of any theorem, please do let me know. No? We are done with the session. There's no test also because we are doing just revision. Na? You guys told me last time when I asked you, na, you guys told me that please go with quadrilateral after this one. So should I go with quadrilateral after this?
Yes, sir.
Quadrilaterals. Okay, then I think we're gonna meet on Monday, na? We will be meeting on Monday.
I think so, sir.
Today is Thursday only, no?
Yeah.
Yeah. Then we will be meeting on Monday. So I will create problems on quadrilaterals. Okay. That one is also
Sir,
important chapter, no? Yes, please.
sir, could you please go to the next page?
Yes, this one.
Yeah, thank you, sir.
You want me to remove the ink? You are taking notes, yeah?
Yeah.
Okay. Anyone want to take note of any theorem? I can show the slides. If you want, I can share this slide with you also. If you are in that group. Okay, I will do one thing. Veer, you are in that group, the Tutorix group, WhatsApp group.
Not yet, sir. Not yet.
Okay, okay. Otherwise, I would have shared the PPT there. If anyone is having any doubt in any theorem, please do let me know.
Done, sir. Thank you.
I can give you a recap. If there's no problem, then we can end this session. We are done with the session. There's no test today.
Yes, sir.
Okay. So, any doubt? Anyone? Please do let me know.
No, sir. Thank you, sir.
Okay. Thank you, Veer. Thank you for joining the class. No doubt. Should we end the session then? I need confirmation from everyone. Aditya, Ali, and everyone. Tamanna, Sravya, Mukta, Kesha. I can see some thumbs flying, but I don't know whose thumb. Okay. Yes, you are saying okay. So, no doubt. Okay. Thank you, everyone. So let me conclude this session. So thank you everyone for joining the session. I hope you gained something from this one. If you do understood everything, then you can okay, okay. If you did understood everything, then I think from this chapter examiner can give you problems around one problem he can give in 5 marks for sure. One proof
Yes, sir.
seven around 7 marks. You can think of around 7 marks from this chapter.
Yes, sir.
One proof they are gonna give you. So I hope you gained something from this one. I will meet you on Monday with one new chapter, quadrilaters. We are gonna revise, and of course, that chapter is not having this much theorems, na? So I will be including some problems where I will be showing you the statement, and you need to solve them first, huh?
Yes, sir.
Okay. From Monday onwards, we are gonna continue with that.
Okay, sir.
If there's any doubt, you can send your doubts to mentor. He's gonna let me know. Huh?
Yes, sir.
I will take a leave then.
Thank you, sir.
Thank you everyone for joining.